All right, let's get right into it. We're going to pull back the curtain on a huge, real-world problem that affects pretty much every product you've ever bought. How do companies figure out exactly what to put on store shelves? What we're going to do here is look at how one company decided to trade its guesswork for data science.
You know the feeling, right? We've all been there. You run to the store for that one thing you need, and of course, the shelf is totally empty. Or, on the flip side, you see these giant piles of products on a massive discount. Well, those aren't just little annoyances. They're actually symptoms of a massive, super complex supply chain problem.
And this is the tightrope that these companies are walking every single day. If you guess too low on how much you'll need, you get stockouts. That means you're losing sales and you're leaving customers like you and me unhappy. But if you guess too high, you get overstocking. Now you've got wasted products, expired food, and tons of cash just locked up in a warehouse. It's this constant balancing act where a mistake in either direction is just incredibly expensive.
So that really gets us to the heart of it all, the billion-dollar guessing game. Let's take a look at why the old way of doing things just doesn't cut it anymore.
You know, for decades, forecasting has pretty much looked like this. You've got spreadsheets, you're looking at historical averages, and then you've got a heavy dose of gut feeling from some very experienced managers. And look, that experience is valuable for sure, but a human brain just can't process the thousands of different signals, things like promotions, holidays, local events, shifts in the economy that affect sales for hundreds of different products across hundreds of locations. It's just too much.
So if the old way is broken, is machine learning the automatic answer? Well, not so fast. The smartest companies, they don't just jump on the AI bandwagon because it's trendy. They put any potential project through a really tough three-part test to see if it's actually a good idea.
Okay, first question. Does it have real impact? And for this problem, the answer is a huge yes. I mean, the potential savings alone are massive. We're talking 5 to 15% of supply chain costs. The scale is enormous. Over 100 distributors, more than 500 products. And this isn't some decision you make once a year. These are weekly decisions that impact the business every single day. So, yep, check. High impact.
Second question, is it even feasible? A great idea is completely useless if you can't actually build it. So technically, this kind of time series forecasting, it's a proven, well-understood part of machine learning. Organizationally, all the critical sales data they need is already being collected. And this is key. They have all the old manual forecasts to use as a benchmark. They know exactly what better needs to look like. And the third and final hurdle, is the data available? Because let's be real, AI is nothing without good data. And in this case, they're in fantastic shape. They have over 3 years of clean, structured sales history. But what's really cool is the potential to start pulling in external data. You know, things like promotions, holidays, even economic indicators to make the predictions that much smarter. So, high impact, feasible, and the data's there. That is a green light for an AI project.
So you've got the green light. Now what? You don't just go and flip a switch and hand over a billion-dollar supply chain to a new AI system. No way. You need a really disciplined plan to prove that it works, and, just as important, to get people to actually trust it.
And this 4-phase plan is just brilliant. First, technical validation. You basically use old data to see if the model would have been right in the past. It's like a simulation. Second, you do pilot testing. Run the AI side by side with the human forecasters for just a small group and see who does better in real time. Third, user acceptance. You actually talk to the people who will use it. Do they get it? Do they trust it? And finally, you measure the real business impact. After 3 months, are stockouts actually going down? That's the only test that really matters.
Now, this is really interesting. Look at how they define success. They actually split it into 2 different buckets. On the right, you have output metrics. Think of these as the model's technical report card. So MAPI, for instance, that stands for mean absolute percentage error. It's a fancy way of saying, on average, how far off is the forecast. The goal here is less than 15%. But on the left, you've got the outcome metrics. This is the stuff the business actually cares about. Are we reducing stockouts? Are we wasting less stuff? You have to measure both, because you can have a model with a perfect report card that completely fails to help the business.
Okay, so we know why they're building it and how they're going to prove it works. Now for the fun part. Let's take a quick peek under the hood at some of the really smart design choices that make this whole thing go.
First off, the system runs in batch. All that means is it creates all the forecasts at once a week. It's not happening in real time. And why do that? Well, the reason is key. It's way simpler, it's cheaper, and honestly, it's good enough. Inventory planning happens in weekly cycles anyway, so you just don't need an instant answer. It's a perfect example of not over-engineering the solution. Next up is a really clever idea called a hierarchical model. So instead of building hundreds of little models, like one for each product, they built one giant global model that learns from everything, all at once. And the huge advantage here, as it says, is that it can make a pretty decent guess for a brand new product, one that has literally zero sales history. That's something that simpler models just can't handle.
Now, this might be the most important design choice they made, keeping a human in the loop. The AI gives its best guess, but the expert planners, the people who live and breathe this stuff, they can look at it and, if they have a good reason, they can override it. This is so crucial. It's not about replacing people. It's about combining the machine's ability to see patterns at scale with a human's deep, on-the-ground knowledge. That is how you build trust in a new system.
All right, so the model's built, it's tested, it's launched, we're done, right? No, not even close. For an AI system, deployment day is really just the beginning of the journey. Now comes the hard part, keeping it honest in a world that is always changing. So the biggest long-term threat to any model is this idea of drift. And this slide breaks it down perfectly. On the left, you've got data drift. That's when the world changes. Your new distributors are different from your old ones. Marketing is running a totally new kind of sale. The data you're feeding the model just doesn't look like the data it learned from. Then on the right, you've got concept drift, which is even sneakier. That's when the fundamental rules of the game change. Think about post-pandemic buying habits, or a new competitor suddenly appears. The relationship between the inputs and the sales just isn't the same anymore. The model's whole worldview is now out of date.
And drift is far from the only thing you have to worry about. You've got all of this to deal with. Things like feedback loops are fascinating. That's where your forecast tells you to stock less, which then causes lower sales, which in turn proves your forecast was right. It's a dangerous self-fulfilling prophecy. And then there's the simple human problem of user trust. If the model spits out a few bad predictions, people will just stop using it, even if it's right 95% of the time. So how do you possibly manage all of that risk? Well, you do it with this core principle. You have to go in assuming that at some point, something is going to fail. The data will be bad, but model will be wrong, something will break. A really robust system is designed for what's called graceful degradation. That just means it has a backup plan, like falling back to a simpler model, or even the old manual forecast, so the entire business doesn't just grind to a halt.
So after all of that, after making the business case, the validation plan, the technical design, managing all those risks, what's the payoff? It's this. The whole point of this entire system is to get a 40% reduction in stockouts. That is a huge, tangible improvement that you would literally feel at the store, and the company would definitely feel on its bottom line.
Look, this kind of AI-powered optimization, it isn't science fiction anymore. It's happening right now, behind the scenes, in thousands of ways that we never even see. Which kind of leaves us with one last thought. If AI can so effectively restock our shelves, what other invisible systems that shape our daily lives is it already optimizing, all around us?